Good morning, good afternoon, and good evening. Welcome to this presentation on the Hyperledger Universal Decentralized Identifier URI specification. This particular presentation focuses on the concept of domain-specific DID grammars, and in particular how they're used as part of or along with the supported capabilities option within the grammar. My name is Michael Herman, and I'm an independent blockchain architect. I live in Alberta on a ranch in Alberta, Canada, and here's a scene of the South Saskatchewan River not too far from where I live. I work about 10 hours a day on blockchain projects and have decades of experience developing and supporting large distributed systems in hostile environments. The purpose of this presentation is to describe the 3x3 matrix model for domain-specific DID grammars, known as DSDG, the DSDG Matrix. And then I'm going to describe how the $supported capabilities option is designed to work with this matrix and designed to work with domain-specific DID grammars. There's a problem or a challenge in the DID community right now where different DID methods need different kinds of capabilities. And how do we capture that in the DID grammar? And the Hyperledger Universal Decentralized Identifier specification is using domain-specific DID grammars as the context for that, and this will become more clear as we go through the rest of the presentation. The primary audience for this presentation is implementers and maintainers of DID software parsers that are built to be compliant with the did-uri specification, and so this could include people that are working with the W3C Decentralized Identifier spec, writing DID resolvers and working with the DID resolution spec, but also other domains such as application domains such as the agent-to-agent communication services in the Hyperledger Indy Agent framework. So a little bit of background. Let's go through the major high-level did-uri-spec user scenarios. The high-level did-uri-spec user scenarios are sort of the high-level abstraction of the more detailed did-uri-spec use cases. The scenarios represent the most common patterns, and it's grown slides, and they're known as slide 45 and 46 traditionally, and slides 47 and 48 have been added based on some recent discussions in the CCG email distribution list. So I'm not going to run through all of these. We've covered them in previous presentations, but you can see that there's some that operate on DIDs. If you go down to 9A, there's one that operates on the DID namespace itself, the DID scheme itself, and also in 9A we can see that $documents also operates at the method level as well to return a default number of DID documents, either found on the DID resolver or found on the DID resolver in the context of a particular DID method. But most tend to work on individual DIDs. The one option that we're going to focus in on is called supported capabilities. And there needs to be a way to query a DID method to understand what capabilities, what options it supports. And so the current thinking is that given this concept of domain-specific DID grammars, they are actually documenting or have different levels of specificity in terms of documenting the capability of a particular DID method. And that's the tact that is going to be taken with the Hyperledger project going forward until it's proven otherwise. Slide 46 here is just some other examples, again, mostly at the did level, but we also see lower down and for being able to retrieve information about the ledger or the did resolver. These are some examples that were taken from the CCG mail list recently related to how would content IDs work. These have been discussed previously in email. And here's a second set of extensions. And here what we're really showing is that how the different options can be composed. So here we see $path being composed with $filter to get version 4 of a particular URL for a particular blog article. 24, it takes that composition a little bit further. We're looking for a blog URL that corresponds with version 4 of an article, and we're looking for the French version of that article, and if the French version isn't there, we'll take the US English as the default. Okay, so let's talk about did domain specific did grammars. This is a build-up looking at a series, in total a series of 9 slides, 9 grammars. They're all subsets of this grammar. They're all subsets of the master did-uri-spec grammar. And the subsets are designed to cater to different needs. So for example, the IPID did method just needs a basic did. It doesn't need any additional capabilities. It's not able to directly support any additional capabilities. So that would be a subset of the master grammar we see here. So let's step through each of the remaining 8 domain-specific did grammars. They are going to work or represent different configurations of the following sections of the master grammar. At the top, we can see that we're not just defining the did as a single rule, but we're breaking it out as the did method, and the did root. Here we're defining the did URI, which is sort of the top level rule. And in its full fleshed out form, there's the did followed by an optional transform. There's the did method followed by a mandatory transform, and the did root followed by a mandatory transform. And we see those that are being defined here. So did optional transform is the did as defined in the first rule, optionally followed by a transform, optionally followed by a path, optionally followed by a query string, and optionally followed by a fragment. The did method transform means that you have a did method. It means you have the did colon method name colon followed by the transform character followed by some transformer option. The did root transform just says we've got the did colon part and then the transformer symbol, the exclamation mark, followed by some transform that operates at the did namespace level, the did scheme level, against everything that's available in a particular did resolver. At the bottom here, we can see that the transformer options rule will always appear at the bottom of the grammar, and by default, it just has one choice, and it's the generic option, which is just a alphanumeric string that starts with an alpha character. And as we look later on, after we finish looking at the grammars, when we look at the 3x3 matrix, we'll see that we have different levels of depth of support. And this is the part of the grammar that will be affected the most. Okay, so the minimally viable grammar, again, I think of this as the IPID use case. So we simply have the same components here as before to define a did, and the did-uri is defined as just being a did and nothing else. So we have no concept of transform characters or transform options. Basically the minimally viable did-uri-spec grammar. The second one is called the simple did-uri-spec grammar, and the numbers are important. The numbers are used to correlate these slides with the 3x3 matrix later. Here, again, almost every grammar will start with the same definitions of did method, and did root. And then we see the did-uri now is the did optional transform rule. So you can still have did by itself, because the next line here indicates that you can have did by itself, but it indicates all the optional pieces. So this is the key difference from the minimally viable did-uri-spec grammar. And then at the bottom we see that the transformer options are still the generic options. So this is the simple did-uri-spec grammar. It's also, you could think of it as the generic grammar for operating on dids, because it doesn't pre-specify what the set of transformer options, allowable transformers options are. Here's an example where we start to see domain-specific did grammars, the whole concept really come into fruition. So this is the did document grammar. So the generic grammars that we saw on the previous slides, they'll handle did documents, but this one starts to get more specific. So again, we start with those same three rules. We have the same definition for a did-uri as the previous grammar. We have the same definition as the did optional transform. But notice down here at the bottom, instead of just saying that the transformer options is the generic option, we're specifically calling out that did document supports select ID, service ID, and exists. And so this is an example of a grammar, what we call a bounded grammar. It's bounded and unbounded, to be technical. It's bounded because it specifies the specific transformer options that are supported, but it's partly unbounded because it still allows the generic option. If we want to make this a tightly bounded grammar, we would remove the generic option from the transformer options. Domain-specific did grammar 4 supports document collections. So this is the ability to query either a did resolver or a specific did method within a did resolver to return a collection of documents. So let's look at that. We're just going to look at the bottom part, partly because of the length of the grammar and partly because it gets repetitive. But here we're saying a did-uri is, as before, it's a did followed by the optional pieces, but it also says that you can have a did method, i.e. the did method name colon, followed by a transform. When we look at the transformer options that can be applied either to the did or the did method, we can see that we've got documents and filter, skip, top, select, exists, the generic option, and the supported capabilities option. The documents option says I want a collection of documents. The exists is to test for the existence of a particular did within a collection, also to test whether a particular did method is supported or available on a particular did resolver, depending on whether you apply this to a did or whether you apply it to a did scheme, did method. Below that, you see filter, skip, top, and select. These are the four of the most common options from the OASIS ISO OData specification. And it's a way of selecting the subset of documents that you want returned from either a did resolver or a particular did method within a did resolver. So filter is a way of passing query parameters, and we saw some of those previously when we were looking for different versions of things or different language representations of things. When you have lots of dids stored on a ledger, did documents, millions and billions of them, you can't just ask for the whole collection. You have to return batches of them. So what OData does is specify a skip and a top option for returning a batch. So skip says, for example, skip the first 100, and then you might say top equals 10 or top equals 20 to return the top 10 or the top 20. Select allows you to control what parts of the did document are returned. And here we see the supported capabilities option. So this is the first time we've seen this, because to do supported capabilities, it needs to be a did method level grammar. So we need to have like line 15 where we see did method transform. So it's not only to support the documents option and the exists option, but you need to be able to specify options relative to a did method to be able to use supported capabilities. And we're going to talk about supported capabilities in a specific example near the end. Here's another version of the did document collections grammar, but this one is a little bit different in that it also supports transforms against the did root. So this is actually the example where you would be able to query all the documents against the did : scheme. The options are the same as the previous one. So the only real difference here is line 16, where we can do transforms against the did root. Well, people might say, what if somebody just says did : exclamation point $documents? Are they going to get all 1 billion did documents returned? No, there's going to be default values specified, for example, for skip and for top. Skip, the logical default is 0. The top might be 10 to get the top 10 back. So there would always be some default controls there that can be overridden. So we've seen so far 5 different grammars, and they represent 5 different sets of capabilities. A little bit overlapping. They're not all mutually exclusive for one another, but the whole idea here is it enables you to create domain-specific did grammars, to be able to name them and ideally store them on the ledger with their associated dids. And then being able to query a particular did method to find out which grammars it supports. And again, we'll come back to supported capabilities in a minute. Here's the minimally viable grammar with support for supported capabilities. So if you remember, the minimally viable did-uri-spec grammar was very small. It only supported the creation of dids. It was the IPID use case. Here, to support supported capabilities, we need to be able to specify the supported capabilities option against a did method. So that's what you see here. We have the simple did rule, like we did for the minimally viable did-uri grammar, but we've added the did method space transform option in line 15 to support, specifically to support $supported capabilities. And if we look down here at the bottom, and instead of just enabling generic in addition to supporting the generic option, we're against did methods. We have the supported capabilities option. Again, technically, if we're very focused here on this truly being the minimally viable did-uri-spec grammar with supported capability support, we would not need line 32, and we would not need line 29. Again, the only place that a transform is used is in line 15 as a transform against the did method. So what we're starting to see, or what you can begin to imagine, is that the different ways of categorizing domain-specific did grammars is a kind of at least a two-dimensional affair, and that'll give rise to the 3x3 matrix in a moment. So here's the simple grammar again with supported capabilities. So here, instead of just a plain did, as in Rule 4, we have the ability to specify a did plus the optional pieces. And when we go down a little bit farther here, this is the same. So the subtleties are subtle in terms of how one grammar differs from the other, but I'll context that a little bit. Number 8. So this is the simple grammar with supported capabilities. And what's different here is it's operating against not only the did with an optional transform, but the did method and the did root. So this is the generic form of the grammar, for example, that could process $documents against the did root, against Rule 6, which is just did followed by a colon. And this is a way of perhaps using the exclamation $documents transform to send a filtered request for documents against whatever's in the did resolver. And we see that here. So actually the end of all the different variations of grammars as far as did documents and did document collections are concerned. Again, there's actually an infinite number of potential domain-specific did grammars. As we saw in previous presentations, dids are used, for example, in message requests, in the agent-to-agent message structures used in the Indy agent framework. So these ones that we've seen before is kind of like an elemental set focused on did documents and did collection. So on one level we have this, the world's simplest grammar here just for dids, the IPID use case. And then on the other end we have this master grammar which supports anything. Anything at the did level, the did method level, as well as the did root level, and it's generic in terms of all the different transform options that are supported. So here's what the domain-specific did grammar matrix looks like. So on the left, the axis is called depth. Across the bottom, the axis is called breadth. So breadth is like the breadth of capabilities or the breadth of support. So the first column is the did column. So those grammars only support operations against dids, not operations against did methods, and not operations against did root. The second column is the did method column, and so it supports operations against dids and did methods. And finally, the third column supports operations across all three. And in terms of the rows, which represent the depth, starting at the bottom, we have the minimally viable did-uri-spec grammars. So the bottom left corner there, grammar number 1 was one of the first grammars we looked at, and you may want to scroll back or rewind the webcast to look at that grammar again. But that's the IPID one. That's the bottom left-hand corner. It only supports DIDs, and it's the minimally viable grammar for DIDs. So no dollar options capability, transform capability at all. Row 2 are the generic grammars. Row 3 are the bounded grammars. So row 3 is where we start to call out specific, the names of specific transform options. At one point I mentioned, there's sort of bounded and unbounded at the same time. So whenever in row 3 you include that generic option as one of the options, then you kind of get into that bounded, unbounded scenario. But if you were to remove the generic option, you'd be in a truly bounded case. So it might be instructive to actually go through those 8 grammars again. I'm not going to do that in this webcast. But you can see that, for example, grammar number 4, which is in the top of the middle row, that's the did document collections did-uri-spec grammar. So there we specified the specific options that you can use to operate against document collections. And it would be document, and 4 would specifically be requesting subsets of documents, batches of documents relative to a specific did method. And so that's where we had the $documents, transform option, skip, top, filter, select, etc. If we contrast that with grammar number 5, which is the top of the rightmost column, it's exactly the same as grammar 4, except in addition to being able to run the documents transform against did methods, you can also run it against the did root itself. So running any did-uri, executing, passing any did-uri to a did resolver using just the did : did root, in case number 5 would have the effect of running against all the documents that are in the did resolver. And so that's the domain-specific did grammar matrix, a way of organizing and kind of highlighting the capabilities of domain-specific did grammar. So let's look at a example. So here we have the common did methods and schemes. Now all of these operate on and return did documents. So out of all of those, technically 9, counting the master grammar, the one that applies here is the number 3, the did document did-uri-spec grammar. And so if you were to take any of these did schemes and execute or pass in exclamation $supported capabilities, what would be returned is the did that is associated with the did document did-uri-spec grammar. The actual technical details of what that did is and how does it get on the ledger, whose scheme is it registered under, etc., are sort of implementation and design details. But this is the most interesting concept, the most interesting solution for being able to create domain-specific grammars and being able to query a did scheme to find out which grammars it supports. So the next steps are the same as before. Bigger, better, faster, trying to find more communities that are engaged using DIDs, and from those communities derive a more diverse collection of higher level did use cases, being able to build and test out the grammar. At this point, we're still hard coding grammars, and they need to be formally verified, as we've discussed in the original Hyperonymy Universal Decentralized Identifier webcast. Continue the outreach in terms of knowledge, awareness, knowledge, and understanding of how to use the spec. This webcast is an example. And again, reaching out to those communities and helping explain how it can be used in these diverse scenarios. So thank you for listening to this presentation for the last 30 minutes. If you're interested in providing feedback, or you have a project where you'd like to use these concepts related to domain-specific did grammars and the did-uri-spec specification, you can contact me at mwherman@parallelspace.net. You can also find me as mwherman2000 on Twitter, and as well as the Hyperledger Rocket Chat, the Sovereign Rocket Chat, and other places. Thank you.